The motor effect is a phenomenon that occurs when an electric current flows through a conductor within a magnetic field, causing the conductor to experience a force. This interaction between electricity and magnetism is the fundamental principle behind electric motors and many other devices. When a current-carrying conductor, such as a wire, is placed in a magnetic field, the magnetic field exerts a force on the moving charges within the conductor. This force is perpendicular to both the direction of the current and the direction of the magnetic field. The result is that the conductor itself is pushed in a direction that is perpendicular to both the current and the magnetic field. The direction of this force can be predicted using Fleming's left-hand rule. If you point the first finger of your left hand in the direction of the magnetic field, from north to south, and your second finger in the direction of the current, from positive to negative, then your thumb will point in the direction of the force. The size of the force experienced by the conductor depends on several factors: the strength of the magnetic field, the amount of current flowing through the conductor, and the length of the conductor within the magnetic field. Mathematically, this force can be calculated using the equation F equals BIL, where F is the force in newtons, B is the magnetic flux density in teslas, which measures the strength of the magnetic field, I is the current in amperes, and L is the length of the conductor in meters that is within the magnetic field. This force is what makes the conductor move, and when the conductor is part of a loop or coil, this movement can be harnessed to create rotational motion, which is the basis of an electric motor. In a simple electric motor, a coil of wire is placed within a magnetic field. When an electric current passes through the coil, each side of the coil experiences a force in opposite directions, causing the coil to rotate. This rotation can then be used to do mechanical work, such as turning the wheels of a car or powering a fan. The direction of the force and hence the motion of the conductor can be controlled by changing the direction of the current or the orientation of the magnetic field. In practical applications, such as in an electric motor, this control is crucial for determining the direction of rotation and ensuring that the motor operates efficiently and effectively. In summary, the motor effect describes how a current-carrying conductor in a magnetic field experiences a force that causes it to move. The size of this force depends on the strength of the magnetic field, the current, and the length of the conductor within the field. The direction of the force is perpendicular to both the current and the magnetic field and can be determined using Fleming's left-hand rule. This effect is the fundamental principle behind electric motors and many other technologies that rely on the interaction between electricity and magnetism to produce motion.